plus 2x minus x minus 2 greater than 0. So in this situation, then I can dissect this. So by the time I dissect it, what do I have? X is common, x into x plus 2. Then here I have minus 1 into x plus 2 greater than 0. So in this situation, I will now simplify this. I have x plus 2, x minus 1 greater than 0. So it should be noted at this point, this is our critical point or level where we are to employ the use of graphical method to fashion out this particular problem. And by so doing, we have a scenario like this. How do you know where the curve will be pointing? We have a scenario like this. If you compare x squared minus x plus 2 less than 0. Okay, we are considering x squared minus x plus 2 greater than 0. That's what I'm considering. Then if you look at this, the model is ax squared plus bx plus c. For example, because this is a model of what? Quadratic equation. But we are considering quadratic inequality. If you compare coefficients, you discover that our a, with respect to this, we have ax squared equals to what? X squared. You can divide both sides by x squared. You divide both sides by x squared, you are going to have our a to be equals to what? 1. And 1 means 1 is greater than 0, which implies that our a is greater than 0. Remember what I said initially, that when a is greater than 0, you are definitely going to have a curve, a minimum curve like this. That is the first pattern. So that is the first information you are collecting. Okay, since you know the direction of your curve, then this is our x-axis, this is our y-axis. Now, we'll now equate each one of these to 0. So by equating each one of them, x plus 2 equals to 0, for example, then which implies that our x will definitely be what? Minus 2. Then x minus 1 equals to 0 implies that our x will definitely be what? 1. Between 1 and minus 2, which one is greater? 1 is greater than minus 2. So it means that minus 2, because you write the lower number first, which is minus 2. Minus 2 will be here. Then 1 will be here. That is the first, that's the second step. Having calculated this or fashioned out this, now the next thing is you know that we are considering a quadratic inequality of this pattern. Now, when this is greater than 0, what it means is that, take note, you have since your curve is this way, this is a positive region. Take note of that, where you have it, because this is your x-axis. This is our x-axis. So the region above x-axis is what? Is a positive region. The region below x-axis is a negative region. While the region beyond the horizontal, that is x-axis, is what? Positive. That means we're having 2 positive regions and 1 negative region. So we can also, what it means is that if we have to consider this, we have a scenario like this where this is minus 2 and this one is 1. Take note of that. And this is our what? X-axis, our y-axis. Now, we will now go back to our quadratic inequality. This is what we have. What is the whole of this is what? Is greater than 0. That means it is positive. And since we know that this region is positive, this region is positive, this region is negative, and this region is positive. Since our quadratic inequality is positive, because anything that is greater than 0 will definitely be positive. So we go to our positive region and shade it. Where is our positive region? This is the first one. We shade this part. Where is the second one? This part. This is our positive region. We shade this part. Now, what it means is that if you look at the 2 shaded parts, they don't have any point of intersection, they are not convergent. So automatically that means they will go separate ways. If they are not going separate ways, the one that is on the negative part, that's when you have your vertical line, which is your y-axis, the one on the left hand side, it's going to be represented with what? Less than. Take note. And the one on the right hand side will be represented by what? Greater than. So it means if I want to write this one with respect to the x as the variable that I'm dealing with, I will have x less than minus 2 or x greater than 1. So automatically this will be the solution to that question. Now, the one I just solved is this very one, when it's greater than. So when I have a scenario like this, where this is my minus 2 and this is what? My 1. And I shaded the positive region, this region and this region. And I said the solution is x less than minus 2 or x greater than 1. Now let's now consider this one, because this one is what? Greater than 0, but this one is less than 0. Let's consider this one. We have the same graph. We have the same quadratic graph where this is our x and this is our y. This is a positive region. You have your minus 2 here. You have your 1 here. This is a negative region and this is our positive region. Now, if you look at this second one, which is x squared plus x minus 2 less than 0. That means the whole of this, which is x plus 2, x minus 1. Remember from what we did earlier. So the whole of this is what? Negative, because anything that is less than 0 will definitely be negative. Now we go to our negative region and we shade. This is the only negative region, this curve. So we shade the negative region. So by the time we shade the negative region, you can see that there is a convergence between these 2 points that you have shaded. Since there is a convergence, automatically, since they are convergent, so automatically you will have minus 2 less than x less than 1, because that means x lies between minus 2 and 1. You can see how this greater than or less than have been able to change our result. If it is greater than, you have a scenario like this. If it is less than, you have a scenario like this. Now, the 12 UTME questions designed for this topic are shown in figure 1.5a on the board. So the first question asks us, find the range of values of x for which this is less than 4. So we have our options. These are UTME questions. So the first question says x plus 2 over 4 minus 2x minus 3 over 3 less than 4 over 1. Let's look at the fraction that way. Then, if you look at what you have, discover that the LCM. Let's look for the LCM. LCM of 4, 3, and 1 should be, that is 12. The LCM is 12. Then we multiply each term by 12. So what it means is that I can try to say this one is a linear expression. So I can say 12 into x plus 2 over 4. So I've multiplied this by 12. Then this one again, there's a minus here. 12 into 2x minus 3 over 3. I've multiplied this also by 12. Less than 12 times 4. Now in this situation, 4 here 1, 4 here 3. So I can write this one as 3 into x plus 2 3 here 1, 3 here 4. There's a minus here. Minus 4 into 2x minus 3 less than 12 times 4. That is 48. The next thing to do is to open this bracket. This times this, that is 3x plus 3 times 2, 6. Minus 4 times 2x, that's minus 8x. Minus 4 times minus 3. Minus times minus plus 4 times 3, 12, less than 48. So let's simplify. Then we have 3x minus 8x, that is minus 5x, plus 6 plus 12, that is plus 18, less than 48. Then we collect like terms. By collecting like terms, I will transfer this one. This one appears like equal sign. So transfer this to this. We have minus 5x less than 48 minus 18. Then minus 5x less than 48 minus 18, that is 30. So what are we looking for? We are looking for our x. Take note, our x has a coefficient of minus 5. And one uniqueness of inequality is that if you divide by minus, the sign will be reversed. The inequality sign will be reversed. If it is less than, it will become greater than. If it is greater than, it will become less than. Take note of that. So if I divide this by minus 5x divided by minus 5, then this inequality sign will be what? Reversed. So it becomes greater than. 30 divided by minus 5. Minus can cancel minus. 5 here 1, 5 here 1. So I have x left greater than 5 here 1, 5 here 6. Remember there's a minus here, it's going to become minus 6. So the answer to this question will be x greater than minus 6. That is option